The next session is one of its kind, and we will see a live demo of Log4j vulnerability. To get the experience, I request Team InstaSafe and Mr. Sandeep Kumar Panda, founder and CEO, to join and show the demo on the famous Log4j vulnerability. Sandeep is the co-founder and CEO of InstaSafe Technologies, a zero-trust security solutions provider based out of Fremont, USA and Bangalore, India. With over 15 years of experience in the domain of cybersecurity and having worked with leading organizations like Symantec and Blue Coat, Mr. Panda has been associated with Cloud Security Alliance, CCICI, and is a leading industry speaker in various security platforms. Sandeep leads the India chapter of Cloud Security Alliance and is a frequent speaker at worldwide cybersecurity industry forums.
Hi all, good morning, good afternoon and good evening. Myself, Srimuki, Security Research Engineer, InstaSafe. Today, we are going to talk about an devastating vulnerability which was recently discovered in the popular Apache Log4j Java logging library. It allows attackers to execute code remotely. And this vulnerability is a potential threat to million more applications and devices across the globe. So now, let's move to the presentation part. So let's move to the agenda. So first we will see the impact of Log4j vulnerability, followed by a description for Log4j and Log4j vulnerability, and a small description for RC, LDAP and JNDI, and followed by Log4j lifecycle. And we can see the steps that are to be followed in the demo, and then demo. After that, finally, we will end up with the mitigation. So now, let us see the impact of Log4j vulnerability. As per the analysis, over 8 lakh exploitation attempts were detected in the first 72 hours after the Log4j issue became public. And then, experts predicted that the Log4j security vulnerability could impact the entire internet because 95% of the Java programs use Log4j either directly or indirectly. And then 1800 plus major repositories have dependency on Apache Log4j library, and these exploits are used in thousands of applications and cloud services. So now let's see a graph that has vulnerabilities from direct versus indirect dependencies. For example, if we take a PHP package, there are 73% direct vulnerabilities from direct dependencies and 27% vulnerabilities are from the indirect dependencies. So now let us see what is Log4j. So Log4j is an open source logging framework that allows software developers to log various data within their application, and it is a part of Apache software. It has 4,000 downloads from its GitHub repository, and the Log4j core is the top to second most popular component by download volume in Central out of 7.1 million total artifacts as of November 2021, and it is used to perform logging information, which can be used for debugging and other purpose. And Log4j has three main components. First one is loggers, appenders, and layout. The loggers captures the log message and send them to appenders, and the appenders deliver log messages to the destination such as files, sockets, or console, and followed by the layouts. These layouts are used to define the formatting of the log messages. So now let us move to the next slide. So here we will see what is Log4j vulnerability. Being used by many business and websites around the globe as a Java language, this software is publicly accessible and used to collect and store records of activity on a server. This vulnerability allows malicious attackers to execute code remotely on any target computer. So basically, it is an unauthenticated remote code execution vulnerability. It has a CV of 44228 and a CVSS score of 10.0. Now let me explain a short explanation for CV and CVSS. So coming to CVE, CVE is a common vulnerability and exposure, which is a list of publicly disclosed computer security flaw that's been assigned with the CVE ID. And coming to the CVSS, it is a scoring mechanism that attempts to assign several scores to the vulnerability, allowing responders to prioritize response and resource according to the threat. And the scores are calculated based on the formula that approximate the ease of impact of an exploit. Here the score is 10.0, so it means the issue is highly critical. And then this log4j allows requests to arbitrary LDAP and JNDI server, and it does not check the response, but it allows attackers to execute arbitrary Java code on a server or any other computer, and finally it leads to the leaking of sensitive information. And the affected versions are greater than 2.10 and less than 2.14. So moving to the next slide. So what is RCE? So the remote code execution attack allows an attacker to remotely execute malicious code on a computer. So the hackers can edit or destroy important files, and he can steal a confidential data, or he can perform a DDoS attack, that's a distributed denial of service attack, and he can compromise the entire system. So moving to the diagram, I will just explain the workflow. Now the attacker writes a malicious script and then he injects the script into a website. After that, the malicious script gets executed and then it will return an error message to the attacker. So now we will see about LDAP. LDAP, that is Lightweight Directory Access Protocol, is an open and cross-platform protocol used for directory services authentication. So it comes to store your information in user account, and whenever you log in an application, the application sends the request to LDAP, and the LDAP verify your identity through authorization server. And if your username and password is correct, it returns the username from the user account. Now let us see about JNDI. So JNDI is a Java naming and directory interface, provides consistent use of naming or directory service as a Java API. So basically it provides an API for application to interact with LDAP. In simple words, Java application cannot directly request to the LDAP because we need JNDI to interact with the LDAP. Now we will see the log4j attack lifecycle. So the first step is an attacker inserts the JNDI lookup in a header field that is likely to be logged. So here the attacker is triggering the logging. And then the string is passed to the log4j for logging. Followed by it, the log4j interpolates the string and queries the malicious LDAP server. And now the LDAP server responds with directory information that contains malicious Java class. And followed by it, the log4j loads an object definition from the remote URL and it initiates an object instance, finally executing the malicious code. So now we will see the steps that are followed in the demo. So we have downloaded the GitLab. We have downloaded the code from the GitLab link. I have mentioned the link in this step 1. And moving to the step 2. So we just clone the repository and then enter into the directory. Just using a simple command called git clone. And moving to the third step, we use a Docker to build an image using the following command. So basically, Docker is a software platform that allows you to build, test, deploy the applications quickly. So using the Docker build command, we are building an image over here. And moving to the next step, we are just running the Docker container using the command docker run. And then we are logging into the server from where we are going to perform the attack. After that, we are just opening a new terminal and starting a netcat listener. So basically, netcat listener is used to intercept the contents of web requests and the network connections. So here it is listening on the port 8055. So once we get connected to the machine, we just get the response over here. So now we are making a curl request. The user agent payload in the curl request triggers the log4j vulnerability that causing the server to send a request to the attacker server. So this 52.38.45.209 is the IP of my machine that is listening on the port 8055, followed by the IP of the vulnerable application that is 52.37.164.160 over the port 8080. So now with the netcat listener, we can able to see the received connection. So the response containing a path to a remote Java class file which is injected in the server will appear. So overall, what has happened above? The payload in the curl request triggers the log4j vulnerability which causes the server to send a request to the attacker's server. So just with a simple 7 steps, we are able to hack the vulnerable application. So these are the following are some of the other payloads that have been caught in the wild. So using this also, we can make the attack. Now I will take you to the demo. So it will show the log4j attack. So after all the installation steps, we are moving to the demo part. So I'm just accessing the application. So we are able to access the application over here. So followed by it, I'm just opening a terminal. Here I'm logging into my Ubuntu machine from which I'm going to start the attack. I'm just doing an SSH command to my Ubuntu machine. The IP is 52.38.45.209. So once I get logged in, I will just start a netcat listener. The port will be listening, the netcat listener will be listening on the port 8055. So after the successful connection, we can see the response over here. So now in another terminal, I am just logging into my Ubuntu machine from which I am just going to start the curl request. So now the connection to the Ubuntu machine is successful. So now I'm just sending the curl request. So the payload in the curl request triggers a log4j vulnerability that causes the server to send a request to the attacker server. So the payload will be the user agent followed by the command JNDI, LDAP and the IP of my machine followed by the IP of the vulnerable application. So here I'm just entering the IP of my machine, that is 52.38.45.209, listening on the port 8055 and followed by the IP of the vulnerable application. So after sending the curl request, we can see the response in netcat listener, and then we can see the response that contains a part of the remote Java class which is injected into the server process. So we can see the response of the netcat listener. And then finally, we can see the response that contains the part of the remote Java class. So now we successfully hacked the vulnerable application. We just logged in without entering the credentials. So now my colleague Avinash will take you to the overview of ZTA architecture.
Thank you, Srimuki. Hi, everyone. Good morning, good afternoon, good evening. I am Avinash, Product Specialist at InstaSafe. I will walk you through the InstaSafe Zero Trust application access, and we will talk more about the architecture and the use cases and what are the features and how we can mitigate the vulnerabilities for the private applications. Now, let us see InstaSafe Zero Trust application access architecture in depth. So in any application accessibility, there are three kinds of components everywhere it is involved in any architecture. So there are the three main components. One is the customer data center end, what kind of an applications we are having and how we want to provide access. And another component is the end users. These two components are very important to provide application access. So now in InstaSafe Zero Trust architecture, we have one more component called controller, which will be deployed, and controller will authenticate the user, verifies the user, and then provides the access control rules to the users and informs to the gateway telling which user can access which applications. So three major components we discussed here is, one is the end user, second one is the gateways which we are going to deploy at the data centers, and the third component is the controllers. So these are the three components. Now, how these particular three components orchestrate each other, how user, controller, and gateway can talk to each other, that is where the secret sauce lies in the architecture. Now, if you see in the representation diagram, we have on our left-hand side, we have end user machines or clients who can connect using the agent installed on their machine. Let us assume Avinash is connecting his agent from his laptop or else mobile device or else any device. Whenever he opens the agent, it will prompt for a username and password and multi-factor authentication. Now, so that means the authentication is mandatory for user to connect. So for this authentication request will reach to the controller. You can see here the dotted lines and the first line, the device verification. The device details are sent to the controller. And now controller will decide either this user is having which kind of authentication mechanism configured. This authentication system can be configured with Active Directory, your identity service provider, any single sign-on solution like your Azure AD or else Okta or else anything can be integrated. And third thing is we will send the authentication request. That means controller will send the authentication request to that particular identity system. Once we receive the approved request, then controller will say, okay, controller verification for the user is done and the device is done. Now controller will say to the gateway, the component which is deployed on your data center. The component which is deployed on your data center will be receives the information about the user connecting to this particular gateway. That means Avinash controller will send the information to this particular gateway stating Mr. Avinash is connecting to the gateway. He will coming from so and so IP address. He will be coming from this particular device. He will be accessing these particular applications. These three components will be sent across to the gateway. Now gateway will understand, will receive the information. Now this gateway will talk. Okay, Mr. Controller, I have the information. Now the gateway will decide, gateway will create a firewall rule for the user who is coming from and the information provided by the controller. That means the gateway will be having a firewall component. That component, the rule will get created by the controller. Okay. So now, after creating the controller, after controller creating the firewall rules, the client agent will establish a direct application access tunnel between the client to the data center gateway, which is deployed on your data center. This we call it as data plane. So now if you see the dotted lines, the connection from the client to the controller and the controller to the gateway, it is called the control plane. So now we are following the split plane architecture on this particular zero trust application access. Using zero trust application access, even though your gateways are deployed, your gateways will act as a dynamic firewalls and can be orchestrated only by the controllers. That means your applications are accessible only when the user device, user and multi-factor authentication are satisfied. So your private applications are secured and can be provided access seamlessly. This is all about the architecture. Now, if you say, Avinash, I have multiple data centers, how can I deploy these gateways? Yes. If you are having multiple data centers, now the hybrid data centers are very famous. It is now we are not limited to the single data center, right? Hybrid data centers we have. Some of applications are on our premise, some of applications are on our AWS, some of applications are on Azure, some of applications are third-party data centers. Wherever your data center is there, we will deploy one gateway component in that particular data center so that user can go and connect to that particular respective application. So this is all about the architecture. So the approach of the zero trust, what we follow is the 4 pillars. First thing is authentication before access to the application. We verify the user credentials, device security poster, and device fence, device location and the user location, and we do user behavioral authentication as well. Once these are all satisfied, then the authentication has been completed. And the second thing, once the user is authenticated, user device is authenticated, what are the next thing is granular access controls are the main component. Controller decides which user can access which application. Now, authentication and everything can be followed, every application vendor can do that. Now, providing granular access control is the majority of the thing. In any solution, we say this particular user, Avinash user, can access application HRMS, application DB, application web server, these three. These three applications can be accessible by the Avinash. Now, there is another user called Srimuki. Srimuki can access only the web application, web server. These two applications she can access. Now, these rules can be created in any solution. What is the granularity is missing in the today's application accessibility is using InstaSafe zero trust approach. you can define access policies based on the device trust score, based on your device location, based on your time of the application accessing, and based on your device security posture. And apart from all this, we can verify either the user is logging in from multiple devices or else not. This particular granularity we can provide when we are providing access to applications for the users. So as I mentioned, these are the two major pillars of the one side of the zero trust. Now we have one side and we need another two sides. We need to cover another two sides. What we need to do in the other accesses, like we have authenticated, we have provided granular access control. And we put intelligence and alerts mechanisms, like for whenever we see a security events, like user copying the content, user downloading the data, and user accessing from a untrusted device. And we will check application reachability from the gateway, either the application is reachable or else not, either it is passing the monitoring or else not. And we can verify all this information and provide to the administrators in real-time dashboard. Right? And here for administrators, we get a lot of invalid login items, and we do put a lot of security functions whenever the user is having a wrong username and passwords or else a multi-factor authentication system and everything. And the third thing is we monitor network devices and behavior of the network, how the user is sending the details and all the information. So using these particular four pillars, we will do the zero trust approach. We put a base for the zero trust approach in any network. And this is the complete zero trust approach what InstaSafe follows. So now with InstaSafe zero trust, what you can do? First thing is your private applications can be restricted access to your trusted devices only. That means we are blackening out your entire IT setup, your data centers, your clouds, everything. That means your hackers cannot see what they can't hack, right? So we are making your infrastructures invisible. Now, what making this infrastructure invisible? We are going to provide access rules, need to know, very stringent, need to know secure application access for your end users. How we are going to provide, I have explained in the architecture. By verifying the device, by verifying the device location, by verifying which time they are logging in from and from which device they are logging in from. We do follow a lot of stringent rules on that particular one. And next thing is allow only trusted and authorized devices. Trusted in the sense, by default, zero trust, never trust any device or else any user. There is no trust at all. Trusted in the sense, the first device by your administrator, but whatever the security rules we put, like having a certain antivirus in place, having machine should be Active Directory domain joined, or else the machine should be having several patches verification, and the machine should be having a particular registry things in that particular operating system and verifying the OS builds. All this we capture and we will say, okay, initially this device is trusted device. And then if any parameters are not matching, we will send authorization request to the administrator over the email, and they can log into the admin portal and they can approve that particular. This is how we allow own authorized devices and the trusted devices for the application access. And once the user is accessing the application, what we need? Granularity, the visibility of user activities, what they are doing, what kind of application they are accessing. These are all needed for the compliance purpose. And at the same time, we need for the application troubleshooting purpose as well. Whenever the user says, my application is having some issue, you go and check the logs and you can go and verify. You can slightly go into the problem directly. The granular visibility of user activity, at the same time, what the user accessed. I give a classic example for this visibility. We do monitor whenever the user is accessing the application, what he is doing inside that particular application also we can record. We can record that particular screen and we can showcase to the administrator. And we will, if the user is trying to copy the content from one application to another application, you can block a unidirection or else bidirection, like allow only copy, disable, allow only the paste one side and disable the copy from to the server end or else to the end user machine or something like that. And apart from all this, you need one more thing. The scalability matters. Unless like regular hardware devices, we don't need to depend upon the hardware. You can scale as you grow. This is all you are going to get. And apart from all this, in the authentication module, InstaSafe can act as a single sign-on service provider and identity provider for your SAML-based application. The second thing is InstaSafe have a multi-factor authentication tool so that you don't need to depend upon any other third-party multi-factor authentication providers. You don't need to integrate your SMS gateways. You don't need to integrate your multi-factor authentication solutions. We have soft authenticator. We have OTPs over the email, OTPs over the email, SMS, and at the same time, we have a soft authenticator which can be downloaded for all the mobile devices, including Android and iOS devices. We are compatible with your Office 365 authenticator and Google authenticators as well. So this is net. These are the features what you are going to get with InstaSafe Zero Trust application access. Now, we want to talk about how the authentication happens and what are the things we can monitor on the user side, right? So InstaSafe as a solution, we follow adaptive multi-factor authentication, behavioral biometrics, high fidelity screen recording. And what is this adaptive multi-factor authentication? Adaptive multi-factor authentication is according to the user login. If the user is logging in from a new device, then we will prompt to multi-factor authentication. Or else as an administrator, you can enforce every time the user need to use multi-factor authentication. And you don't need to enter the OTPs. We can send a push-based notifications to the mobile applications which are installed as well. Sounds crazy, right? Yeah, similar way how all other players do. And behavioral biometrics. These behavioral biometrics are very key point where we have implemented. This is when the user is typing the username itself, the authentication gets started here. We see either the correct user typing or else not. We see the problem, how fast the user is typing the key and what is the depth and what is the time taken between one keystroke to another keystroke. All these things we monitor, and then accordingly we will decide and we will provide a score, and according to that we see either correct user is logging in or else not. If you see any change, let us say a classic example here, if Avinash is having a username and password and the multi-factor authentication, and so that these all three can be spoofed. This can be sent it to Avinash, can give it to one of his colleague or else one of his colleague or else a friend to log in on behalf of him. So that Avinash, okay, Avinash, username has been given to Srimuki, password has been given to Srimuki, and then OTP also shared to Srimuki. Now, if Srimuki is typing that username and password, our behavioral biometrics will identify, okay, this is not Avinash, this is someone else. Your pattern is not matching, so that Srimuki will never log into the application at all. This is the beauty of the behavioral biometrics. This is the next generation authentication system need to be followed for all the solutions. So, and we do follow, we do provide screen recording and disable the screen capture, cut, copy, paste, and all these things. So why the screen recording and cut, copy, paste are needed? As I mentioned earlier, if you have any compliance-based application or else if it is a sensitive application, whenever they are accessing that particular application, we can record the entire screen and then we can showcase it to the administrator on demand. And using InstaSafe Zero Trust application access, you can securely provide access to any application without compromising on the data security. User cannot take a screenshot. User cannot copy the content from that particular application. User cannot paste any new content to that particular application. Administrator can define completely on that particular part. And we do provide in the authentication system SAML-based support for all of any applications. That means InstaSafe can act as a single sign-on service provider for any SAML-based application. At the same time, if you are having any SAML single sign-on solution, we can integrate with that particular applications as well. And we completely do disable the clipboard access for the user so that user cannot copy the content from the server side to the end user and end user side to the server. And what you need is a log retention. We can do the log retention and we can do the real-time threat monitoring when the user is accessing these particular applications inside the data center. So this is all about the authentication and monitoring. Now coming to the core features, what all the I can say the features which can be helpful for a lot of our audience today. We can provide secure application access, all policy-based segmentation. We can configure multi-cloud peering or else multi-data center peering. And we can, all these things can be configurable from the single pane management console, which is completely web-based solution. And you can access it from anywhere. And you can restrict it to only to the certain IP addresses and certain geolocations as well. Right now, you can say, if you say SaaS portal, any SaaS portal, you can't restrict to that particular geolocation or else particular IP address. So here you can restrict. Administrator can log in to InstaSafe administrative console only from this particular IP address, or else only from this particular geolocation, or else only particularly from this particular country. These all things can be configured. And we do browser isolation. That means whatever the web applications you have, internal web applications, that web applications can be accessed inside our isolated browser, which is included in our agent. And then you can avoid all your DDoS attacks and the cross-site scripting attacks using this browser isolation. And geo-binding and geo-fencing features. That means you can bind the user to that particular geolocation or else a geo-fence to the particular thing. And here, any solution is like you can log in from n number of devices, right? So that here what we do is we will restrict only this particular number of devices can be used by Avinash. That means one mobile phone, one laptop, one tablet. That's all. If the new device is logging in from again, it will go to admin approvals, right? And we do follow in full-blown AES 256 encryption between all the communications. The data in transit is completely AES 256 encrypted, and all the logs entered in the solution can be sent across to your SIEM servers as well. So these are all the core features and the use cases you can define for to the audience today. And if I want to do a quick recap quickly in 2 minutes, InstaSafe Zero Trust application access can provide inbuilt multi-factor authentication system, inbuilt single sign-on solution system, and we provide policy-based access control rules completely with a lot of restrictive controls like geofence, geolocation, geobinding, and application access time like general shift, and you can define the shifts according to the user needs, and we can provide all the activity logs can be provided to the administrators. User activity logs can be provided to the administrator, and we can disable the clipboard control, and we can disable the screenshot features for whenever the user is accessing the applications. And majorly, the device binding and device authorization is the concepts which need to be followed and which needs to be provided for any zero trust application access solution. So all the devices should be authorized and authenticated by the administrator and by the controller so that the application can be accessible to the end user. That's all from my end. Now I will pass it on to my colleague Srimuki again to showcase the demo for how to avoid the vulnerabilities like Log4j using the Zero Trust application access from InstaSafe. Thank you.
So the first mitigation is like upgrading a vulnerable version. At a minimum, FOSSE recommends upgrading the version to 2.16 or higher to mitigate the critical RCE vulnerabilities, and then followed by replacing the affected classes for the releases from 2.0 to 2.10, and then disabling the JNDI lookups for the versions of Log4j greater than 2.10. And finally, reducing the attack surface using Zero Trust Application Access, that is ZTAA. So now let us see the demo, like how to reduce the Log4j attack using ZTAA. So in this demo, we are going to see how to minimize the attack using ZTAA. So now I'm just accessing the application outside ZTAA, so the IP won't be reachable. So we cannot access the application outside ZTAA. So after that, I'm just logging into my ZTAA agent. So I'm just entering my credential over here with the username and followed by a password. So now we are into the agent. So we can see our Log4j application over here. Now our application is here. So now we are just connecting to the application. So it is getting connected to the gateway first. In a few minutes, we can access our application. Yeah, now our application is here. So with JTA, we just saw how to overcome or how to minimize a log4j attack. So thanks to everyone for watching the presentation. Hope you all liked it.
The Log4j vulnerability allows malicious actors to execute code remotely on any targeted computer. Thank you, Mr. Sandeep, for showing the live demo, and it was great learning for the industry and also for me as well.